So we had the commissions, the markups, markdowns, discounts, stuff like that are applications of percents. Now we've got one topic to finish up here in the second hour before we have time to review for our test. And that topic is interest. And we're going to start out talking about simple interest. Now, simple interest is the simplest form of interest that we can calculate. What simple interest does is it does not calculate the interest unless there is some sort of an action that takes place. So let's say you take out a loan and you don't do anything with it until it's time to repay it. The interest does not get charged till the very end. There's no action. Every time you try to make a payment, well, then they're going to charge you interest because that's an action on the loan, or anything that you're doing to change the balance. But basically, simple interest is nothing happens until the end of the account or end of the loan or whatever, and then the interest is charged before it's paid off. Or if it's an investment, it's charged before you drop back out, or added in before you drop back out. Simple interest is governed by a couple of formulas. The maturity value, or the future value, is equal to the principal plus the amount of interest. So in other words, the principal is what you're starting with, the interest is how much you earn through your investment, so the maturity value is what you have at the end. Or if it's a loan, it's what you owe at the end. The bigger formula, the more important formula, is the amount of interest. The dollar amount of interest is equal to the amount of the principal. Again, that's that starting dollar amount, times the rate. Now the rate is your percent, but it's in decimal form. So 6% would be 0.06, and so on. Times your time. And your time is always expressed in years. So let's say that you invest $6,000 at 4% for 3 years. How much will you have at the end of the 3 years? Well, our first step is to find the amount of interest. The amount of interest will be our $6,000 times the rate is 4% will become 0.04. And the time is 3 years. So what is that, $720? Is there interest? Is that what you come up with? So the maturity value is the principal, 6,000, and I'm going to write it like this, plus the interest of $720. So $6,720. Any question there? Now this is not terribly practical because no bank is going to let an account sit there for 3 years and not add interest to it. Simple interest is almost never used on that long term of a loan or an investment or whatever. Simple interest is almost never used on anything more than 6 months. So simple interest would make more sense on something like this. Let's say you're going to borrow $4,000 for 3 months at 9%. How much are you going to have to pay back at the end of the 3 months? Well, again, we got to find the interest. The amount of the interest is the principal, $4,000 times what? 0.09, our rate. Times, now 3 months, we said the time was always expressed in years. Well, 3 months, it's easier to do it just 3 out of 12. If you try to change it into decimals, it can get ugly for the wrong. If it was 2 months, it'd be 0.1666666666666. Sorry. Anyway, it's late at night. Anyway, what's that come out to be? $90 in interest. So at the end of the 3 months, 4,000 plus $90 you would pay back $4,090. Any questions? So let's look at a little bit of algebra mixed in with this, huh? At 8% interest, how long would it take for $8,000 to grow to $8,960? Now looking at this, we're going to be using that I equals PRT formula. But do we know the amount of interest? Sort of. We can find the amount of interest. How? Yeah, we started at 8,000, we grew to 8,960. We're going to subtract those. So you give us $960 as our interest. Do we know our principal? Yeah, we started with 8,000. Do we know our rate? 8%, so 0.08. Do we know our time? No, we're asking how long. We're looking for the time. So now we're going to go ahead and we're going to combine everything that we can. 8,000 times 0.08 is 640. Then what? By 640. 1.5 equals t. What's that mean? Time is always in years, so 1.5 years. What do you think? Not too bad? Still better than a sharp stick in the eye?
Yes.
Sure? Okay. What's that? Depends on the day. Let's say Pat pays 7% interest on an auto loan. Last month, the interest was $47.60. Find the balance at the beginning of that month. Okay, do we know the amount of interest? Yeah, $47.60. Do we know the principal? No, that's what we're looking for. Do we know the rate? Yeah, 0.07, 7%. We better know the rate because we are missing the principal, right? Time. 1 month, 1/12 of a year. Now, if we were to multiply 0.07 times 1/12, we are going to get a really ugly decimal. So we're going to have to be very careful how we do this. So the 4760 isn't going to change. This is going to be P times. Now my calculator, 0.07 times 1 divided by 12 is going to give me this ugly decimal, 0.005833333. If I write this down and try to punch it back in, it is going to be rounded off. Even though my calculator, though, is displaying that many digits, it is still, the calculator is remembering the whole number. So I have to do what's called keeping it in the calculator. So I'm going to write it in here just for something to do. But now what I'm going to do is I'm going to divide by that number. I got to get rid of it, right? On my calculator, though, this is what I'm going to do. I'm not going to clear it at all. I'm going to leave it just like that. And I'm going to type in 47.6 divided by, and instead of trying to type in 0.00583, blah, 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 I'm going to hit second. Then ANS down here says previous answer. All of your calculators should have a key similar to that somewhere. Usually it's down by the equal sign. Usually it's on your negative sign. That's telling the calculator, I don't want to type it back in, but use the answer to the previous calculation here. Hit enter. I get $8,160. So the previous balance at the beginning of the previous month was $8,160. What do you think? Good stuff? You know it? There we go. Didn't come up with that? Okay. And of course, yeah, if you make a mistake, then you're in trouble. You got to go back and do the 0.07 times 1/12. You work with it. Okay, so we said simple interest only applies to short term, less than 6 months. What happens if we have longer than 6 months? Well, they usually use something called compound interest. Compound interest means every little while they figure out the interest and they add it to the account. So let's go back to our first example. You're going to invest $6,000 at 4% for 3 years. But here's the kicker. Compounded quarterly. What does that mean? Every 3 months, 1/4 of a year. They're going to figure out the interest, add it in. Then the next quarter, the next 1/4 of a year, there's going to be interest on top of that interest. Hence the word compounding. So in quarter 1, the amount of interest is our $6,000 times 0.04. What's our time? A quarter of a year. 1/4. $60. So what that means is we start quarter 2 with 6,000 plus 60, or $6,060. So our interest for that quarter is 6,060 times 0.04 times 1/4, or $60.60. So that means we take 6,060 plus $60.60. We're going to start quarter 3, $6,120.60. How many times are we going to have to do this calculation? 4 times would be 1 year. For 3 years would be 12 calculations. I don't want to do this 12 times. So it's time to look for a shortcut. Now we talked about this in the first hour. This is an increase problem. We start with this amount. The $6,000 is 100%. And we're adding interest to that. But notice here it is 4% interest, but only 1/4 of it, because it's 1/4 of a year. What's 1/4 of 4%? 1%. Right? 4% divided by 4 is 1%. So the ending balance here is 100 plus 1, or 101%. If I found 101% of 6,000, it's going to be 6,060. In fact, I can shorten it up even further. I can take 6,000 times 1.01. Where did 1.01 come from? 101% put as a rate or decimal. It's going to give me 6,060. If I multiply 6,060 by 1.01 again, what am I going to get? $6,120.60. I'm just multiplying by 1.01 over and over again. How many times? 12 times still. Well, there's a shortcut in math for multiplying by the same number over and over again, and that is a power, or an exponent. So 6,000 times 1.01 to the power of 12. $6,760.95. If you recall from the simple interest calculation, it was $6,720. We gained an extra $40.95 because of compound interest. Now, over 3 years, that doesn't seem like a big deal. Over more years, that gets to be big in a hurry. So just a little example that I have to show to clear my conscience. How many people in here are 25 years of age or less? Just a few of you. Okay, huh? 25 age or less. So let's say 25. Now, retirement, it's already been said that I can't retire until like 67 or 68 to draw full Social Security. And it changes. It's going to change every year. So we're just going to do 70. Because if you're 25 years old, it'll probably be 69 or 70 before you get there. What that means is you're going to have, I know this is a depressing thought, 45 years of time to work to save up for retirement. Now, once you're right now you're in school, you might be living kind of cheap to make ends meet while you're in school. A lot of people, they get out of school, they get that good job, they get a better job, they're making more money, and they want to improve their quality of life. They want to buy a new car, or buy some toys, a snowmobile, or four-wheelers, or new furniture, or whatever, move into a nicer place. But if you kept living the way you are now, living as cheaply as you can and saving money, and just took that money from your new job and put it away, you could probably save quite a bit. Anybody think 5,000 out of line?
So that's what their parents died?
Well, no, just for a couple years. If you want to keep living until you die, actually there was a survey done. And it was a little off topic. A little over a year ago. It was the graduating class of 2000, high school class of 2014. So this is last year's 2004, I should say. Last year's 2014. So 10 years after high school graduation, it was 70-some% of them were either still living with their parents or had moved back in and were living with their parents. So 3/4, 10 years after high school graduation. That was in the United States. In other countries, that's very common. In Italy, it's very common for 3 or 4 generations to be living in the same household, but not so common here. Now, if you're going to leave money in there for 45 years, you can actually make a really good annual percentage return. If you look at the stock market, I know in the last 7 or 8 years it has been horrible, but if you look over any 40-year period from the beginning of the stock market over 120 years ago, even periods that include the Great Depression in the 1920s and 30s, the average annual gain on a 40-year investment is between 12 and 13% per year. So let's say that we can make 12%. So that means at the end of the year, you'd have 112%. Right? You're 100% plus 12%. That's 1.12. And we're only going to compound once a year to make it simple for ourselves. So 45 times, power of 45, because 45 years. Now, before I punch this in the calculator, anybody want to guess what this is going to turn out to be? $819,938. Over $750,000. That's pretty good. Now, let's say you decide, you know what? I worked hard to get through school. I've got this good job. I deserve better things. I'm going to buy a new car. I'm going to buy some toys. I'm going to go on vacation. I'm going to move into a nicer house. I'm going to spend some money and enjoy this. I'm young. What the heck? And you wait. And at 35, you decide, okay, I've had some fun. Now I'm old enough I can start worrying about retirement. That same $5,000. Assuming that you can still get 12% per year, even though it's only 35 years. Anybody want to guess? This is depressing. $263,998. Waiting that 10 years, cut it to less than a third. Less than 1/3. That is very, very significant. Now, here's where you're going to see me cry. I'm 42, so let's just say 45. If you wait till you're my age to start doing this, and a lot of people do, they wait till they get within 15 or 20 years of retirement before they start worrying about it. That same $5,000 for me, only 25 years, assuming I can get 12% or average 12%. Let me steal myself before I do this. $85,000. Compare that. I get about 1/10 of what you would get if you started at 25 compared to me at 45. Now this is just putting $5,000 away once. That's a big difference. That doesn't mean it's too late. I should not worry about it and just plan on working forever. The sooner you do it, the better. But let's do some little significant work here. I'm going to start at 20 because there are some students here that can graduate by 20 or 21. And we'll go up to, I don't need to go all the way up to 80. Let's go up to 68 because that's estimated full retirement age for a lot of people. For contribution, that's how much you're going to put away. So you're going to put away $5,000 a year for all those years. So the balance, anybody want to take, I'm going to do this here quick. Make this numbers. Anybody want to take a wild guess at what this is going to come out to be? About $10 million. Yeah, that's 12%. Let's say the economy's down and it doesn't come back up. Let's just change that to 10%. Now this is going to make a depressing difference, but let's do it. Your 10 million is going to drop a bit to 5 million. So the difference between 10% and 12% makes, you're thinking, oh, I'm only getting 4% on my money. I could get 6% somewhere else, but it's only a couple percent difference. So there's your couple percent difference. That's big. Now what we did before was just putting the 5,000 once. This is putting away every year from 20 to 68. $5 million. How many think you could retire off $5 million? Yeah, I probably could too. I would make a go of it at least. I might even go early if I had that right now. But let's do this. A couple of numbers to compare. Let's take this person here and say, you know what? They graduate at 20. I'm going to save my money and I'm going to put it away for, let's just go till like 28. So you know what? At 29, they decide, I've saved for 8 or 9 years. I've had enough. I want to play with my money. Out of that 5 million, how much do you think they're going to lose? What are they going to go down to? Still got more than half. Still got $3 million. That's at 10%. If it was 12%, it'd be a lot more. Let's say this person gets out of school, and like we said, you know what? I worked hard. I deserve to play. And then at 29, they decide, okay, I'll start putting money away for retirement. How much do you think they're going to have? Less. This person here put away for 8 or 9 years. This person started at 29 and put away for 40 years. Significantly ahead. that first 8 or 9 years of your life out of school is worth more than the rest of your life. Now, for those of you that are older like me, I'm sorry to point that out, but it doesn't mean basically the sooner you do it, the better. Okay? Any questions? Now that I've totally shot everybody's mood for the night, you're happy because you're still young? There you go. Have I mentioned my retirement plan, by the way? I put this out there to every class. If you ever hit the lottery and become a multimillionaire, I will accept a free room above your garage. Just slide some scraps of food under my door. I'm not hard to maintain.
Michigan with me?
I don't care if it's a free room. Okay. Anyway, I'll go anywhere in the United States for free room and board. But anyway, there is a new quiz due tomorrow. That's Friday at 11:59 p.m. There is new homework due by class on Tuesday. And of course, test on Tuesday. And yes, we do have like 23 minutes. I am going to do some review for those who want.